Hello. Welcome to Green Thought. So, did you guys know that the synthetic dye that we use every day is one of the major factors that contributes to the water pollution around the world? But how do we want to overcome this problem? The answer and the solution is Curcumin-Based dye. And without further ado, let's jump into our project presentation. Hi, it's me again, Adli. So for this part, we want to talk about the project background. So, what is curcumin-based dye? Curcumin-based dye is one of the chemical compounds that we can find in the turmeric. So what is the benefit that we can get from using the curcumin-based dye? It is both natural and sustainable. Before we go deeper into the study, let us introduce you guys with our components of indications. So the label indications have three main components. The first letter indicates the modern use. The first one we have C, which is copper sulfate, and the second one we have V for vinegar. And the second letter, it is for the dye that we use. The first one, which is N, it indicates natural turmeric dye. And the second one, which is C, it is for commercial dye. And last, which is S, it is for synthetic dye. And the third part, which is the numbering, it refers to the fabrics used. First fabrics, which is cotton. The second one is thick koshibo. And the third one, the last one, which is thin polyester. Now, we want to tell you guys what we want to highlight in the study. The project is mainly want to highlight the producible method for the curcumin-based dye. And the second one, we want to see the effects of using different types of models and fabrics can contribute to the results. And the third one, which is we want to see the impacts for the environment while using the curcumin-based dye and synthetic dye. So now let's move on into the predictions and the expected outcome of the study. First, we want to see whether the curcumin-based dye can be effectively used in different types of fabrics. And second, we want to see whether the curcumin-based dye is actually differ in color fastness for different types of moderns, the temperature and the fabric use. And the third one, we want to see whether is it true that curcumin-based dye is actually more environmentally friendly than synthetic dye. And all of these three are some of the basis for our hypothesis. With research ethical standards, the chemicals used are properly disposed to protect the environment and human health. Additionally, we uphold the research integrity by sharing our results transparently.
A study from Abdullah Hossain in 2021 stated that synthetic dye is not environmentally friendly and has a negative impact on the wearer skin, where synthetic dye is used in colouring and producing textile products. Therefore, natural dye is a good substitute and more environmentally friendly in colouring and producing clothing and textile products.
In the same study, the moldating process using metallic mordants effectively prepared the fabric for dyeing with curcumin by treating the fabric at 80 degrees Celsius for 50 minutes and conditioning it for 1 hour. The moldating agents enhanced the fabric dye uptake and improved the colour and light fastness properties. Washing and drying ensured the removal of excess mordant, resulting in evenly treated sample. This process demonstrates the importance of moldating in achieving vibrant, durable and light-resistant colours in various textiles.
Now, let's start with the materials. For this study, we work with 3 types of dyes, which are natural dye that was derived from fresh turmeric, commercial powder turmeric, and also synthetic leather dye to spot the difference between each type of dye, whether the color stain will last better or not. Our fabric choices represented a mix of textures and composition, which are cotton, thick koshibo, and thin polyester. These choices allow us to study how different fibers interact with the dye. To fix the dye to the fabric, we experimented with 2 mordants, which are copper sulfates and vinegar. We also tested the dye with the fabrics with no pre-treatment process to benchmark our result. This mordant not only helped to bind the dye but also to influence the final color and quality.
Now,
Let's move through the material and methodology that form the foundation of our project, which is utilizing Curcuma longa, that is commonly known as turmeric, as a sustainable natural dye for textiles. We had 3 stages of methodology, which are preparation of the sample, where we prepare the turmeric dye, and the fabrics that will be used to test the dye. Utilizing the dye, where we tested the dyes on fabric, and lastly, obtaining the results, where processes such as washing and drying are involved. Next, let me take you through the methodology step by step. We started with the preparation of fresh turmeric. After cleaning and cleaning the leaves, we cut them into small pieces and air dried them for 5 days. Once dry, the turmeric was whipped and grounded into a fine powder and whipped again until the resin became constant. The turmeric powder was then stored in airtight ziplock. This step was crucial to maintain the consistency of the dye throughout the experiment. Next, we turned our attention to the fabric. Each piece was cut into uniform size of 20 cm by 20 cm. Before dyeing, the fabrics underwent pre-treatment with the mordants, vinegar, and copper sulfate separately. This step ensured that the dye could penetrate and bond effectively to the fibers. Once treated, the fabrics were hung to dry for 24 hours and were ready for dyeing. The next stage, in which utilizing the dye, began by boiling water with 3 different beakers, then cooling it down to 70 degrees, where it was a good temperature for the turmeric to release its pigment. All types of dyes was mixed into the water, stirred thoroughly, and the solution was filtered to remove any solid residues. The fabrics were then immersed in the dye bath for over 30 minutes separately, ensuring they absorb the vibrant color. Once dyed, the fabrics were hung to dry naturally with low temperature for 24 hours. The final stage of the method is where we tested the durability of the dye, where we soak up the dried dyed fabric, tap water for an hour, and hung to dry the fabric at room temperature for 24 hours. This step allowed us to evaluate how well the dye adhered to the fabric and its resistance to washing. By following this systematic approach, we could gather meaningful data on the effectiveness of turmeric as a natural dye.
This slide summarizes the comparison between the best, which is vinegar natural turmeric using cotton VN1, and worst, which is vinegar synthetic dye using cotton VS1 dyeing result. Let's break down the finding. The best result were achieved using vinegar natural turmeric cotton VN1 as a mordant. Here's why: vinegar significantly improved dye absorption on all fabric, including natural fiber like cotton and synthetic ones like polyester and coshibo. It enhanced color intensity, making the colors vibrant and uniform. As a mordant, vinegar also increased color fastness and durability, particularly on natural fiber. On the other hand, vinegar synthetic dye cotton VS1 showed the worst performance, especially on natural fiber like cotton. The colors were dull and uneven with poor bonding to the fabric. Despite intensive pre-treatment, synthetic dye still did not perform well on natural fiber. Overall, synthetic dye was less effective compared to natural dyes with vinegar. In summary, natural dyes with vinegar as a mordant outperform synthetic dyes in terms of color vibrancy, uniformity, and durability, making it a better choice, especially for natural fibers.
Wow, the color is so pretty.
Of course, this is the result of our project. Pretty, right?
This project has been a success, and here's an in-depth discussion of our findings and their implication. First, we developed an eco-friendly and efficient method for utilizing turmeric dyes derived from Curcuma longa. This method not only maximizes the use of natural resources but also highlights turmeric as a biodegradable and non-toxic alternative to synthetic dyes. Next, we analyzed the effectiveness of turmeric dye on different fabrics. The results showed that turmeric dyes perform best on cotton, moderately on coshibo, and less effectively on polyester. This proves that turmeric dye is highly compatible with natural fiber, making it an excellent choice for sustainable textile application. Our testing revealed that turmeric dye produces vibrant and long-lasting colors that are resistant to fading and washing. This durability enhances its potential for practical use in industries where color quality and longevity are crucial. One of the key achievements of this project is its environmental impact. Turmeric dye is biodegradable, making it a safe and eco-friendly alternative to synthetic dyes, which often contribute to pollution. This aligns perfectly with the global push for sustainable practices. Finally, this project demonstrates the potential to reduce environmental harm through improved dyeing method. Turmeric dye not only meets industry standard but also support the transition to a more sustainable and eco-friendly future.
Conclusion, curcumin work well as a natural dye for different fabric including cotton, polyester and koshibu. Treating fabric beforehand with mordants such as vinegar or salts greatly improve how well the dye bonded to the material. The dyed fabric showed good result for washing. While the colour was vibrant and durable enough for lighter users, curcumin still faces challenges with fading in sunlight or being cost-effective compared to synthetic dyes. However, since curcumin is a natural, biodegradable and sustainable, it has strong potential for eco-friendly textile dyeing, especially in markets that value sustainability.